Hello. So welcome to today's lesson on volume. I'm going to be going through a few of the problems from the textbook, section 13.4. We're going to start, I think, with problem 7, and then problem number 9, and problem number 10. I hope that everyone is doing well. We're going to be taking a look at a PowerPoint presentation. I'll go ahead and bring that up. And now I need to share my screen with you. So let me share. Give me just a second. Okay, so hopefully everybody can see the PowerPoint presentation. We're looking at more volume examples from section 13.4, set A. First, we're going to take a look at problem number 7. Number 7 says, consider the pyramid in problem 6, part A, which has a square base, and that base is 10 units on each side, and has a height of 12 units. Part A of problem 7 says, suppose one of the sides of the base is doubled to make a 10 unit by 20 unit rectangle, but the height remains the same. What is the volume of the new pyramid? Remember that to find the volume of a pyramid, we use the formula 1/3 times the area of the base times the height. This gives us 1/3 times, and then to find the area of the base, since it's a rectangle, we multiply 10 units times 20 units, and then we multiply that by the height, which is 12 units. This gives us 1/3 times 200 square units times 12 units. And so we got 1/3 times 2,400 cubic units, and that makes 800 cubic units. So notice that the answer to problem number 6A was 400 cubic units. So by doubling one side of the base, we've doubled the volume. Okay, next we're going to take a look at problem number 7, parts B and C. Part B says, suppose the slant height is doubled from 13 to 26, and the base remains a 10 by 10 square. What's the volume of the new pyramid? Okay, so looking at the pyramid from the side, we get a right triangle where one leg is 5 units and a hypotenuse is 26 units. We need to figure out the height of the pyramid. And we're going to do that using the Pythagorean theorem. We'll do 5 squared plus the height squared equals 26 squared. And that tells us that the height is the square root of 651. Again, to find the volume, we use the formula 1/3 times the area of the base times the height. And the base is a rectangle that's 10 units by 10 units. So to find the area of the base, we multiply 10 units times 10 units. The height is the square root of 651 units. And so we get 1/3 times 100 square units times the square root of 651 units. And that gives us 100 over 3 times the square root of 651 cubic units, or in other words, approximately 850.5 cubic units. Part C asks, how do the volumes of A and B compare? And we can say that the answer to part B is bigger. Next, we're going to look at problem number 9. It says if the height is doubled in the two cones in exercise 8 and the radius remains the same, what happens to the volume? We're going to start with part B first. This cone has a height of 2 units and a base radius of 1.5 units. We're going to double the height, so the new height is 4 units, and the base radius remains 1.5 units. We'll use the formula volume for a cone is 1/3 times the area of the base times the height, and that is 1/3 pi r squared times the height. The base is a circle, so the area is pi r squared. We'll plug in 1.5 units for the radius and 4 units for the height. So we get 1/3 times 2.25 pi square units times 4 units, and that makes 3 pi cubic units. I'm going to pause now. I'm going to stop the recording. Give me just a second.